Oh, I'm sorry. I'm sure that was very, very noisy. And honestly, it's not a mistake. There's really three reasons for that. Yes, I am eating right now. And the three reasons would be one, I'm annoying. Two, uh, I like to bug you guys and I'm hungry and I want goldfish and carrots. And three, because we're learning about sound this week. That's right, students. Finally, we're on really our second to last topic of the year. And I just wanted to introduce you this week to the assignments, and then we're going to do the first lesson. And I'm really going to try and get it under 15 minutes, which is killer when I eat carrots for half a minute of that. So first of all, I'll just ask read the weekly update carefully. I'm not going to go through it as much this week. A lot of the similar stuff. Um, if you're looking for any of the overall information for the week, this is the place to do it. I always recommend you read this first. There's a lot of links here that are important. They have the frequently asked questions. If you have any questions, this might be on there already for you. Uh, and then the slides for the week. And then these next couple ones I want to talk about for a second. The schedule for the week, it'll be the same as last week, literally exactly the same in terms of who's going to be having my Google Meets and when. But this week, I'm asking you to complete your Baldy course elective form as well, which I talk about right here. Basically, next year you're going to be taking electives, and if you want to have a say in what electives you're taking, this is your opportunity to do it. You can't complain next year when you get the thing that you didn't want to do when you didn't say you didn't want to do it, or vice versa. So, real quick, in Class Dojo, if you were to go on to the Class Dojo site, you should scroll down past Miss Cherney's post about signs and this and that, down to Mr. Minna's 8th grade course catalog. There's a catalog here. This basically just means, hey, these are all the different courses. Read through that carefully. I'm really looking to do this once only. Don't ask what your friends are going to be doing. Do what you think is interesting, is going to forward your ability to get into the high school of your choice that you want to go to. Not oh yeah, my friend loves media arts, so I'm going to do that even though I hate it. It wouldn't be wise. So once you've looked at that course catalog, you click on this link here and complete the Google form. And once you've done that, you should be set to at least tell the school what you want to do for next year. It might not be a guarantee that you're going to get those courses. This is what the course catalog looks like. Um, this is where it describes each of those courses once. There may be some changes in the form itself because sometimes it's updated a little bit afterwards, but this is the best thing to review before you going into that form. The form itself will look like this. You go in there, you select your advisor, it's 18 pages. It'll take a little bit of time, but it's just basically trying to see which ones you like the most to make sure that you get the best possibility for your choices. And then always check out the schedule for the week. I posted that there as well, but it's on Class Dojo. Okay, now in terms of expectations for this week, you're going to have 5 assignments. Here are the slides we're going to get back to in a second. 5 assignments. We have guided notes for each of these assignments that you'll find posted to each assignment. And a lot of people have been asking, hey, do I need to do these? And the answer is you don't have to do my guided notes, but you have to do some guided notes. You should not. You have to do some note taking. Do not look at a video and think that you've gotten it all just by listening once. You should be going slowly through it, taking time to take notes, maybe going back a little bit. Say, oh, what did he say there, or what does that really mean? Sometimes even like looking up terms as you see them on the internet is a great way to learn based on what your real needs are. Don't just go through and say, hey, I don't understand this. You really have no way of getting an excuse for that because you have the internet right at your fingertips already. So if you need to, just take a pause, search up the term. It might be that I'll get to it a little bit later in the lesson, and that's where also taking notes on things that you don't understand as you go through the lesson might be helpful as well. And I expect that you bring some more guided notes here in the last set of guided notes. I expect that you bring those kind of questions to the Google Meets. Though they're optional, they're definitely recommended. This week I'm going to be trying to play some music during each Google Meet for Sound Week, and I'll try and explain a little bit more about each of those different instruments during those times. So come on out to those during the posted times. The fourth assignment, you'll be doing a lesson in eScience 3000 on applications of sound. And the fifth assignment this week, you'll be doing Properties of Waves Introduction. It'll be another just basically simulation on waves, sound waves, water waves. Lots of good examples here to go through. A lot of people have been like what maybe looks like they're just faking the data and then coming up with the right or wrong conclusions based on that data. Some people, I think, genuinely are trying to do the best they can, but they're just not getting the good data. So during these simulations, always do your best to make sure that you're carefully taking measurements. Because if you're not getting good measurements, you're just going to end up either having to lie about them, or really, what would be worse, I don't know about worse, but making stuff up or getting it wrong, thinking it the wrong way, when this is supposed to help reinforce the correct understanding of it. And even maybe have you ask some questions. So those are the 5 assignments. And that being said, right now, please, you should be clicking on assignment number 1 with the guided notes link and have that up, or be taking your own notes as we go along, and we'll go into this week's learning. So this week is about sound. Last week we talked about waves in general, and you should know by this point that sound is a wave. And even stepping back a little bit further than that, we talked about energy. So sound is a form of energy, and the type of energy it is kinetic. It's matter that is in motion, and it's energy passing through matter that's in motion. In terms of waves themselves, if you have not studied that yet, or if you haven't studied energy, please go back and take a look at the videos, at least from those last 2 weeks, so that you understand what we're talking about this week. Okay, so the objective today, or whenever this is that you're watching this video, describe energy as a property of an object associated with light and sound in order to describe how light and sound energy are transmitted by waves. All right, sound waves. You've probably seen something like this if you've ever, what you think about as seeing a sound wave. You think about it as traveling into the ear, but that's very different from what it actually is in real life. Not only is sound a longitudinal wave, and this is a transverse-ish kind of wave here. It's an interfered wave, but it doesn't look like this. There literally isn't anything to see about it. It travels across many different things, and we'll get into it right now. So this specific objective for this lesson, describe sound energy as a property of an object associated with the rate of vibration and the medium through which it travels, in order to explain the relationship between vibration, medium, and wave properties. It's all about relationships right now. You 7th graders love your relationships, so why not talk about the relationship between sound energy and mediums? All right, so what is it? This is maybe a more accurate representation of what sound is, even though you can't necessarily see it. You can see the effects of it. You might have thought of any one of these pictures when you say, what is sound, right? Oh, sound must be, when you're making a lot of noise, or when you see fireworks, they're very loud. Instruments make sound. And down here in the bottom right corner, you have a tree. One question people have asked is, if a tree falls in the woods and nobody's around to hear it, did it make a sound? And so we said, what is sound? So I want you to go out and do your typical thing where you're going to ask a family member or just somebody that you can yell to on the sidewalk as they walk by. Don't talk to them too close. A tiny piece of space junk hits a space shuttle, right? Just imagine that this is maybe either an astronaut or an alien that's sitting outside a space shuttle watching a space junk hitting the space shuttle. All right, one's in the capsule and one's outside. Can either of them hear the impact, and how? Take a minute to go ask this question and then come back. Okay, so if you're coming back right now, you may have heard any kind of range of answers of they both hear it, or one hears it only, or neither of them hears it because there's no sound in space. I would say probably they both hear it, but for different reasons than most people think. For one, you have the person inside this shuttle where these vibrations from the junk hitting the space shuttle carry through the air into the person's ears, so they will most likely hear this, unless the air had already sucked out of the shuttle itself, in which case they would be dead anyway, so they wouldn't hear it. And then you have the astronaut that's sitting outside. The reason an astronaut outside might hear it isn't because the sound waves can travel over space. So you can see these waves, these disturbances don't go out to the astronaut, but because they have a radio in their helmet that uses radio signals, which is light, which travels over nothing at all. So weird to think that when you listen to the radio, you're not listening to sound waves getting transferred over time and distance. You're actually listening to light that gets turned into sound. So if that's all confusing, fantastic. You're ready to learn about sound, and especially how it's different than light. So the astronaut in the space shuttle can hear the impact because there's air in the space shuttle, right? And if you remember from last week, sound is a mechanical wave. It's something that needs a medium to travel through, and so there's a medium to travel through in this space shuttle. It's air. Most of what you think of as sound, when you hear sound, is sound traveling over air as well. But the astronaut has nothing to hear it with. But in reality, if this astronaut doesn't have a way of communicating to this person, like using a radio, they're basically dead anyway. So yeah, as much as you've been lied to by Star Wars and a million different other movies, there is no sound in space. That's not to mean that this astronaut might make sound inside of his spacesuit when he farts, oh my gosh, or that the Death Star made sound if you're on the Death Star. But if you're sitting out in space, there will be no way of that energy transferring to you through empty space. All you would see is the light energy coming off of it. So what is sound, right? Sound is a form of energy just like electricity and light. If you're going along in your notes here, please make sure you're taking your guided notes. And the next question will be, how is sound made then? So just like all waves, it starts with some kind of a disturbance. When you hear a disturbance, you think, okay, my cousin, oh man, he's disturbed. It's not like that kind of disturbance. It's more of a back and forth motion. When matter is made to move back and forth, we call it a vibration, just like a pendulum goes back and forth, and it returns to the position it was in before. Now, the wave itself can sometimes move in the same direction as that vibration. We call those longitudinal waves, and sometimes the wave travels in a perpendicular direction, or 90 degrees to the disturbance. We call them transverse waves. In the simulation last week, a lot of people got that wrong. They said, oh yeah, it's a transverse wave, but the matter moves perpendicular to the wave. And it's actually, I'm sorry, parallel, but it moves perpendicular. So if you did that on your PHET sheet, go back and take a look at those comments. It will hopefully be helpful. So how is sound made? When air molecules vibrate and move in a pattern, I'll wait for that, called waves or sound waves. So sound is created by these vibrations that produce waves of energy that move through matter. Now, that matter is key. It can be any kind of matter. Some forms of matter transfer energy better than others, and we're going to talk about that in a minute. But let's just not forget, right? Waves are energy, and sound is a wave, so therefore sound is energy. It's just a specific form of energy. Okay, so what is a vibration? I think there's a lot of different thoughts about what this means. A vibration is a back and forth motion. When basically you hit a tuning fork, most people don't know what a tuning fork is anyway, or you pluck a string, or you speak. There is something that is going back and forth quickly, usually many hundreds of times per second, that causes the air around it, or whatever material is around it, to vibrate. If I were to knock on my desk right now, I'm creating a back and forth motion in the wood that causes a back and forth motion in the air touching the wood that carries up into the microphone that I'm speaking into right now and causes that to vibrate. The vibrations travel in waves away from the object always. So sound is one of those weird things where it's not just in a straight line, it's basically in all directions away from the thing itself. I'm going to stop it here for the next video. Don't forget to watch the next one.